There are two techniques in subsurface investigation. One is direct method and indirect method. Now, before letting into the types of subsurface investigation, let us understand what do you mean by subsurface investigation. What are the things we can get from this investigation? Now, we need water, and for getting that water, we are dependent on the groundwater. Majorly, 30 to 60% of water requirement in India dependent on the groundwater. So it is necessary to understand the subsurface layer of the soil. Why in a particular place where we have ample of water and why in a particular place we don't have any water, or during the winter times the water might come and during summer days the water will not come in the same bore. What is the reason for that? What is happening below the ground level? These things we can investigate by the two methods. Generally, subsurface investigation is identifying the occurrence. We know that the water is being penetrated below the ground by the rainfall. Through this, the water gets percolated from the top surface and it goes below the soil. Now, here you can understand that wherever there is a river flow, below that you will be having high amount of water percolation. Now the continuous amount of water will also be there. Wherever you find the river course, in that direction the groundwater will also flow generally. If you go far away from that, you can understand that this water will immediately get penetrated inside in days. If you put bore here, you will get continuous supply of water. Why? Because you have a river source, you have a surface water source, so this water gets penetrated. What happens if you are putting a bore wherever the ground level is very high and there is no source of the surface water and water percolation? If you are boring here, for some time you will get water. Why? Because after several years this water will penetrate in horizontal direction. Now generally the water will penetrate in vertical direction, the surface water. Also the water will percolate in horizontal manner because due to the pressure. Now what happens, this water, if you are putting a bore here, sometimes you will get all the water which has already been percolated here, you will get. What after that? If soon as the water has been completed, again the water requires years to get recharged. Then only this bore will come into active state. So this is the reason you have to study the groundwater level. You have a confining bed here. Below that the water is very rare. If you take this water, it will not recharge immediately or quickly. So you will get for some time an amount of water you will get. And if you go deeper into the ground surface, you can see that again you have a confining layer. Below that you have a aquifer. And here if you are boring and taking the water, this water is being penetrated before millennia, before hundreds and hundreds years before it is being percolated inside. That water you are consuming now. What happens? This water have high mineral content, high natural contamination. So whenever you are boring it, if you are taking this water, it will be harmful to the humans. Whenever the water you are taking from an unconfined aquifer, the water will be very fresh and good to consume. Natural contamination will be very less. It helps in locating the aquifers, selecting the suitable sites for well. The same way whichever I have discussed here, if you are digging a open well here, there will be some water. Soon as if you dig the water, dig the soil, but after some time you will not get the water. So for these reasons we need subsurface investigation where we are interested. Now what are the objectives? To locate the groundwater bearing formations. If you do an investigation, subsurface investigation, you can understand that what are the layers below the soil. Starting from loose sand, much denser, you will be getting some clay layer and some semi-solid rock, and solid rock might be formed. So like that, different layers are there. Whenever you have denser layer, there is a high chance of not getting water. If you drill more deeper, you will be not getting much water because there is a confining layer. So here you can understand the location of confining aquifers. Where are the layers? You have this aquifer. So to determine the depth of groundwater, and you will not get water immediately below the soil because of its seepage, from where it gets recharged and how it moves away. These things you can understand and estimate the thickness of aquifer. If you have an aquifer here, what is the thickness of this? So according to the thickness, you can find the volume of water which is available and identify the recharge and discharge zones. If you consume this water, how many months or how many days it will take to recharge this same groundwater, you can identify. Now access groundwater quality and identify what is the contamination here and what is this contamination. Even though all are the groundwater, you can find the contamination level in this aquifer versus this aquifer. So according to the aquifer level, the contaminations might differ. Mineral classifications are there. This reduces the drilling cost before a bore failure. If you want to know the groundwater directly, if you are boring like this is the first method of identifying the subsurface investigation. First one is physical formation by drilling or excavation. First thing what you can do is, there will be a drilling machine here. This will bore the ground and you can examine when the water gushes into the pipe. You can understand that that is the level of water. So from there you get the water. If you go deep, that much of volume of water you can take it. So this is a test drill. Imagine if you don't have water here, you have to redo the bore in another location. So this is called a test drill. You can identify the depth of water, examine the underground formation, what are the layers below the ground, which gives clear identification, depth, thickness and type of aquifer. Generally in India, 40 to 60% of bore wells fail due to improper site selection. Number of cases we would have heard. I have bored here and for some days the water came. After a month we are not finding a water. 40 to 60% of bore well fail due to improper site selection. Geophysical investigation can improve bore well success rate up to 70 to 80%. And let us understand what is geophysical technique. In direct investigation, well logging. What do you mean by well logging is, imagine you have to find the aquifer. In all the places below the ground you will not find a water. This is called the water bearing strata. Here you can see a aquifer here and there is a water possibility. If you are boring at each places, you can identify the water availability. If you bore it for 210 meter, there is no water here and you are constantly boring at different distance. At some particular distance you can see that there is a water in this place, and if you go further you cannot find. So soil below the ground will not be same level. You can see the level of weathering formation might be different. Clay layer or alluvial layer, sand layers might be at different levels. Investigate that and find the depth, and below that you can find the solid strata. Now this is called well logging or bore log. Before constructing a house, you can have a bore log report, study of existing wells and bore wells. Next thing is trial pit. Trial pit means there is a small excavation is being done to understand the shallow groundwater condition. This is not suitable for deep groundwater. For shallow groundwater, wherever you have well and nearby ponds are there, at these places you can use trial pits. Next thing is pumping test, generally done by governments and some private large organizations are doing this pumping test. What do you mean by that? In the sense, you will be boring here and you pump some amount of water. Whenever you are boring, you can find the natural level of groundwater. This is called a casing, and you will be putting a pipe here and there will be a submerged pump. So in this casing you will be finding a aquifer here. All the water will get penetrated into this case and it will come out. Submerged pump will take the water and it will supply. So in this casing you can see that soon as if you start pumping, cone of depression of groundwater is called cone of depression. Imagine you are pumping 1 lakh liter of water. So after how many days that same water level, at the same water level it reaches. So we can understand that this drawdown will reach its natural level. So how much days it took in order to recharge this place. This is called a pumping test. That much of water is available, you can constantly take that. So this will give a healthy groundwater consumption. Next thing, areas receive annually less than 700 mm rainfall a year. It is better to do a recharge potential test, that is a pumping test, and proceed. Weathered zones of thickness 15 to 20 meter. There is a natural process called weathering. Wind always takes particles and it distributes all over the world. We know that northwest wind and southeast wind will flow. It takes all the dust and it forms the layer of the sand. So this layer is called weathered layer. Like that, if you find 15 to 20 meters of weathered layer, there is a high possibility of unconfined aquifer where you can find a good amount of water. Indirect method of exploration. So far we have discussed direct method. What are indirect methods? Are electrical resistivity method. We are not exploring the ground either by taking samples or drilling. We are just using some scientific technology and principles to identify the soil layers. Second method is seismic refraction or reflection method. This I will be discussing in detail. Third method is remote sensing and photogeology. What do you mean by photogeology? Is through the satellite you can understand the overall layer. It is very difficult to do a bore for a state, for a village. It takes more work and more fund is required in order to do detailed information. Using remote sensing and photogeology, you can identify the lineaments and the fault zones, geomorphology, drainage pattern, natural drainage pattern. If you find the drainage pattern, the same way the groundwater also has a drainage or seepage pattern. These patterns can be identified by the remote sensing. Then vegetation cover. Next thing is GPR, ground penetrating radar. You can see this kind of equipments are there. This is used for shallow depth analysis. If you run from one place to another in one direction, it gives you the layer of soil. What are the layers below the ground? Sand, gravel and sandy gravel. What are the depth? These layers are available. It gives in the linear direction. So you have to move into different places in different spacing in order to observe the soil level and get the subsurface investigation report. This is the next level of high resolution imaging of shallow water tables. Next thing, electrical resistivity method. This is commonly used method in order to identify the groundwater. Now in this method there is a advantage. Mostly it gives best result for groundwater detection. Its principle is to send electricity, to send the current through these two probes, and these two are receivers. When you have more resistance or less resistance, according to the level of resistance, the layers are identified, and water has some amount of resistance in ohm. Electrical resistance is measured by ohm. So according to that, you can identify this layer as water. So this is called electrical resistivity method. Why it is called? We are sending electricity or electrons and we are finding the resistance of each layer. That is why it is called electrical resistivity method. This is most commonly used for groundwater exploration. Profiling. What are the profile below the soil? This test is useful for finding the subsurface investigation below 30 meter and 120 meter depth. Peninsula part of India, these are commonly used. Now it can also find moisture content, porosity, permeability and mineral composition. So according to this you can understand what might be the qualitative measure of water, how the quality might affect groundwater parameter. You can understand by doing the electrical resistivity method what are the layers of soil which is available. Now what is this principle is, there are two electrodes. Here is the source of voltage. There are two electrodes where the current is supplied, and these two are called potential electrode where the voltage is measured. How much voltage you are sending, how much you are receiving, how much is the resistance. According to the resistance, different soil have different resistance. Sand, clay, granite, water have different resistance. So we can find the individual resistance and we can match with the common resistance to find the water level. This indicates low resistivity, generally indicates saturated zones where you might find clay or saline water. In water you have saline water and normal water. So if it is very less in the sense, it might be saline. High resistivity in the sense there is a dry formation, you don't have any water, massive rocks or compacted areas are there. So there are two types of electrical resistivity. One thing is called vertical electrical soundings, VES. It is used to determine the variation of resistivity with respect to the depth. Next thing is, if you want to get the 2-dimension or 3-dimension, you can use electrical resistivity tomography. This gives only one-dimensional. This is an example of vertical electrical soundings. Here you can see four number of probes are there. Two are used to send the electricity, two are used to measure. By this connection, this is a battery. So from here the power source is there, and this is electrical resistivity tomography. The same way you can find four number of wires and different probes are laid here. This gives 2D and 3D images of subsurface. This is used to find aquifer depth, weathered zones, thickness and borewell location. Whereas electrical resistivity tomography gives fractured mapping, contaminated studies and detailed groundwater investigation. So from this, whenever you are providing these two probes, this is being measured as the length, distance between the two probes. Can you see here? 1, 2, 3. So there are 3 layers. You can see the distance here, and whenever you send the electricity, it is being measured here. The same way, it is being taken to next level, and the distance will be equal. At a distance of A, you will be taking to the next layer and you will be sending the electricity and finding the values. So if you take it to a single stretch level, you can find that what are the resistance. The resistance are mapped by this. This is having 42, 42. In the sense, this is the same layer. So you have to map and connect this. Whenever you are connecting, you will be getting this kind of tomogram. This is a 2-dimension. Here you can see there is a high possibility of water, and in what depth the water is available, and what is the resistance, what are the different layers are here in the same profile. Like this, you have to run along the different layers in order to get a complete 3D image. You can convert 2D into a 3D image. So a typical resistivity values. You have eager of knowing what are the different materials. If you are doing this test, you are getting a resistivity of 0.01 to 0.1 or 1. There is a massive sulfides. Graphites, these minerals give a less value. Generally the water, salt water gives 1 or less than 1 resistivity. Then you can identify that there is some groundwater, but this is a salt water. If you have a resistivity of more than 3 to 100, you can understand that there is a water availability, there is an aquifer there, and there is sea ice and permafrost, etc. Like that, according to different resistivity, different types of soil, different types of mineral, you can understand. These are weathered layers, etc. So here all the values resistance are given here, and you can understand that the productive borewell zones are commonly found in 30 to 120 meter depth. If you go too much deep and if you find that water, what happens? Once if you consume that water, the water will not regain. The desert zone thickness above 15 to 20 meter is favorable. Borewell success rate improves by 70 to 80% using resistivity survey. Blind drilling failure might reach 40 to 60% of hard rock areas. Now, next thing, what is second method? It's called seismic method. What do you mean by seismic method is, here the same way you will be having this kind of probes at different locations. There will be a hammer here and there will be impact here. If you impact this, automatically the vibration will be passed and it will be observed by this probe. We are sending some sound waves and this sound waves is reaching to the different probes. These probes will observe the sounds. By the time taken for this observation, you can understand the layers, you can understand the different composition of soil. This is the way seismic method is used. Similar to electrical resistivity, you have two methods, reflected and refracted seismic method. Reflected method, immediately after each and every layer, the waves are being reflected and it is being taken. Refracted is, and after traveling into a distance, it will be taken by refraction. Now, the waves are recorded using instrument called geophones. So, these are called geophones, and this helps to identify the depth of layers. According to the depth, the sounds will differ. If you strike every material, the material has different sound. Glass, if you strike a glass, it has a sound. If you strike a rock, it has a sound. The same way, different material has different sound. So, their propagation of sound waves are different. This is the key principle here to understand the hardness of rock, faults, sand and gravel aquifers. Now, seismic method is based on the study of propagation of artificially generated seismic wave. This is not natural seismic wave, this is an artificial seismic wave. Whenever you strike a hammer, one seismic wave is generated, similar to earthquake. Now, this gives density, elasticity, moisture content, degree of compaction and rock hardness. This gives the understanding of groundwater exploration, but these are only used majorly for oils. So, where we take the mineral exploration, oils, tunnel alignment, dam site investigation, etc., where these methods are widely used. Now, types of seismic method I have told, one is reflection method and another one is refraction methods. We use seismic refraction method for lower layers. You can see, soon as the hammer strikes, this wave is being reflected. The blue color is called reflections and red color is called refractions. It travels through the body and is being taken here. These applications are different. Refraction method is being used to identify depth of bedrock, weathered zones, fractured zones and groundwater occurrence. The reflection method is being used for the oil and gas exploration, deep aquifers and structural geology studies. This is a image which gives you understanding. Here you can see the person, he is striking with a hammer. You can see it has been connected. This hammer, how much of impact is being produced, which is being measured here. There is a source of hammer and geophones. So like this, the geophones are fixed in a line. From here, this will be fixed and you have cables and seismograph and recording system is here. Soon as the hammer strikes, these reflections are being measured. According to the velocity, if you get 300 to 600 meter per second, then you can understand that it is loose soil. If higher the velocity, you can find more stronger the strata. If there is loose soil, there is a possibility of getting unconfined aquifer and water. The advantages are, it is a non-destructive method, economically compared to blind drilling. Both the methods, the geophysical methods, both are very economical, covers large area quickly. If you want to bore there, it nearly takes 4 to 6 hours, even 12 hours to bore a particular place and to a particular depth. Now it is not like that. You can quickly go through. It helps scientific groundwater management. If you do a pumping test, you can understand the recharge efficiency. Cost of comparison. Blind bore well may cost around 80,000 to 2 lakh per failed well. But when you are doing geophysical technique, it only costs 10% of drilling cost. Here, sir, you have given different methods, direct methods and indirect methods. Which method shall I use? Which is most effective? When you are going for electrical resistivity method, this is vertical electrical resistivity method. This can be used when you have a typical depth of 30 to 150 meter. Maximum depth you can go up to 300 meter. Cost is around 300 to 10,000 per point. Cost level is very low here. This is used for groundwater exploration. Then electrical resistivity tomography. This is used for depth 20 to 100 meter and the maximum depth of 150, where you are doing a 3D, 2D and 3D images. So here it takes around 20,000 to 80,000 per line. Cost level is medium. This will give you a detailed subsurface imaging. Why? Because you are getting a 3D image. You can understand how much of volume of water is there. Now seismic refraction and reflection method. Seismic refraction is used for 10 to 100 meters, and you can see that seismic reflection is 50 meter to kilometers. It can go into very deep. And maximum depth it can go to 150 meter. Cost is around 50,000 to 2 lakh, and it is used to find bedrock depth and foundation. Seismic reflection method generally is not used to find the groundwater. Then this reflection methods are used for very deep, and it can give an idea of oil and gas deep aquifers. Remote sensing technique and GPR, these two techniques I have discussed. This is used for indirect methods as a reference method, where the cost is very low or medium. The remote sensing softwares are available, where you can get in some places for free. You can understand the regional groundwater mapping, and this cannot give a particular place and in-depth analysis. GPR is used for very shallow places for nearly 1 to 10 meter of typical depth. Maximum 20 to 30 meter it can go. Cost is around 10,000 to 15,000 per day, and it shows only shallow utility lake.